students, welcome to Anne's classes. Let's do exponents, chapter 5, exercise 5a. And we are doing question 6. Express each of the following in the exponential form. And the first one is 512. Writing in the exponential form means expressing this number in a particular form where you will have a base number raised to a power or an exponent, and the answer should be 512. Now, how do we write this in the exponential form? So 512, if we have to put it in the exponential form, we have to write all the prime factors of 512. We have to do the prime factorization method. So that is, we have done this earlier, where you divide this number 512 by prime numbers. So let's start with 2. So starting with the first one is 5. So 2 2s are 4. We are doing short division. 2 2s are 4, but this is 5, isn't it? So what is left? 1. So now our number is 11. So 2 5s are 10. And again we have one number left because 2 5s are 10. This is 11. So we have 1 there. Now our number is 12. 2 6s are 12. So 2 into 256 is 512. Now we're going to continue dividing this with 2. 2 1s are 2. Now go to 5. 2 2s are 4. And what is left? 1 is left. And now it is 16. 2 8s are 16. So 2 into 128 is 256. Continue with 2. 2, 1 you can't do. So take 2 along with it. So it becomes 12. 2 6s are 12. 2 4s are 8. Now continue again with 2. 2 3s are 6. 2 2s are 4. Again, let's continue with 2. 2 1s are 2. And that number is 3. So 2 1s are 2. So there's 1 left. So that becomes 12. 2 6s are 12. Then continue with 2 again. 2 8s are 16. Again, we'll continue with 2. 2 4s are 8. You can use 2 again. 2 2s are 4. You continue. 2 1s are 2. So we've used the prime factorization method and we have got 2's here. Let's count the number of 2's. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that means 512, when you write it in the exponential form, it is 2 raised to the power of 9. Okay. So as you can see in the prime factorization method, when we kept dividing the numbers by 2, we got 9 2's. So 2 raised to the power of 9 will give you 512. Next one, let's continue this also in the same way. So let's take 1250 and let's divide this by 2. So you can't divide 1 by 2, so we take 12. 2 6s are 12. Next number is 5. 2 2s are 4. But there's 1 remaining, so this 1 is carried there. So that becomes 10. So 2 5s are 10. So 2 5s are 10. Now we're going to use 5. We can't divide this by 2, isn't it? So we're going to divide it by 5. 5 1s are 5, but that number is 6, so there's 1 left over. So the next number is 12. 5 2s are 10, but the number is 12, so 11, 12, 2 is left, so number is 25. 5 5s are 25. So we have 5 into 125 is giving us 625. Now continue with 5. 1 you can't divide, so you take 12. 5 2s are 10. 11, 12. That's 2 left over, so that becomes 25. 5 5s are 25. Now we have only 25 here. 5 5s are 25. So let's write 5 5s are 25. When you continue, 5 1s are 5. So the exponential form here, when you write it, first we write 2 into 5 into 5 into 5 into 5. So 2, there's only 1. So we write 2 as it is into 5. How many 5s do we have? 1, 2, 3, 4. So that will be 5 raised to the power of 4. So the exponential form of 1250 is 2 into 5 raised to the power of 4. Next one, we have 1458. Let's do it the same way. So 1458. Let's divide it by 2. So 1 you can't do, 14. 2 7s are 14. Then you take 5. 2 2s are 4. So there's 1 left. So that becomes 1 there and 18. 2 9s are 18. So let's continue this with 3. Now, how do we know that this number is divisible by 3? Remember the test for 3, test of divisibility by 3. We have to add up these numbers. And let's see. Let's do it separately here. 7 plus 2 plus 9. Let's see how much we get. 7 plus 2 is 9. 9 plus 9 is 18. 18 is divisible by 3. That means 729 is divisible by 3. So this is the test for 3. So we can use 3 here. So let's see, 3 2s are 6, but that number is 7, so there is 1 left. So we have 12 there, 3 4s are 12 and 3 3s are 9. Now is this number divisible by 3? Let's check and see. 2 plus 4 plus 3. 2 plus 4 is 6, 6 plus 3 is 9. 9 is in the tables of 3, so this is divisible by 3. So 2 is not divisible, so we'll take 4 along with it, 24. 3 8s are 24, 3 1s are 3. Okay, is 81 divisible by 3? Let's check. 8 plus 1 is 9. Yes, it is divisible. So let's use 3 again. 3 2s are 6, 7, 8. There's 2 left, so it numbers 21. 3 7s are 21. Now this we know is in the tables of 3. 3 9s are 27. Then we continue with 3. 3 3s are 9. Then we again continue with 3. 3 1s are 3. So what are the numbers that we get after prime factorization? We have 2, there's 1, 2, and then we have 3s. Let's count the number of 3s. 1, 2, 3, 4, 5, 6. 3 to the power of 6. So this is the exponential form of 1458. You can straight away write like this, or you can expand it and then come back to this answer. Next one is 3600. So let's try that. 3600. Let's begin with 2 again. So 2 1s are 2. There is 1 left, so that's 16. So 2 8s are 16, and then you have the 2 zeros. So we can continue again. 2, you can't divide 1, so take 18. 2 9s are 18, and then you got the 2 zeros. Now since it's ending in 0, it's all divisible by 2. So 2 4s are 8, and what's left? 1, so that's 10. 2 5s are 10 and 0. Now continue again. We can use 2. As long as the number is ending in 0, we can use 2 because it's an even number. 2 2s are 4. Here also 2 2s are 4, and there's 1 remaining, so that becomes 10. 2 5s are 10. So now we cannot use 2 anymore. Let's use 5. Let's take 20. 5 4s are 20. There is 21, 22, 2 left. So the number is 25. 5 5s are 25. So continue again with 5. 5 9s are 45. Now we can't use 5. I'm going to use 3. 3 3s are 9. Continue again. 3 1s are 3. So let's write all that. Let's start with 2. So how many 2s do we have? 1, 2, 3, 4 2s. So let's write that. 2 into 2 into 2 into 2. And then we have 3s. How many 3s do we have? 1, 2. We have 2 3s. 3 into 3. And then we have 2 5s. 1 and 2. So that will be 5 into 5. So let's write this in the exponential form. So 3600 in the exponential form will be 2 into 1, 2, 3, 4, the power of 4 into 3 raised to the power of 1, 2 into 5 raised to the power of 1, 2. So this is our answer. 2 raised to the power of 4 into 3 raised to the power of 2 into 5 raised to the power of 2. Question 5, 1350. So let's begin that. 1350. Let's begin to use 2. So we'll use 2 here. The first number is 1. Take the next number with it. It's 13. 2 6s are 12. And we have 1 left, which we'll put here. Now the number is 15. 2 7s are 14. Again, we have 1 left, which we'll put here. So it becomes 10. 2 5s are 10. So now we are not going to use 2 anymore. We're going to use 5. 5 1s are 5. The number is 6, so there's 1 left. The number 17 now. 5 threes are 15. 16, 17, that's 2. Now the numbers 25. 5 fives are 25. Continue again with 5. 5, we have 13 there. So 5 twos are 10. But we have 11, 12, 13. That's 3 left. So 35. 5 sevens are 35. Now continue with 3 this time. 3 nines are 27. Again continue with 3. 3 threes are 9. Continue. 3 ones are 3. So now 1350 in prime factorization method. What do we get? We get 1, 2. Now let's look at the threes. How many threes do we have? 1, 2, 3. So I'm putting in the order of the numbers. So first I put 2. Now I'm putting 3. 3 times 1, 2 and 3. And then let's see the fives. How many fives do we have? 1, 2. We have 2 fives. 5 into 5. Now I'm going to put this in the exponential form. So 1350 will be 2, only 1 raised to the power of 1. So we leave it as 2 into 3. How many 3's do we have? 1, 2, 3. So that will be 3 raised to the power of 3 into 5 raised to the power of, we have 1, 2. 2 5, so 5 raised to the power of 2. So this is the exponential form of 1350. 2 into 3 raised to the power of 3 into 5 raised to the power of 2. Question 6, 1176. So 1176. So here let's begin with 2. The number is 11. So we're going to say 2 fives are 10. But there's one number left, so that's 17. So that will become 2 eights are 16. And still there's one number left, so we'll put it here. So that becomes 2 eights are 16. So 588, we're going to continue with 2. Now 2 twos are 4, but the number is 5. So there's one left, so it's 18 there. So 2 nines are 18 and 2 fours are 8. So let's continue with 2. So that's 2 ones are 2. Then the number is 9. 2 fours are 8. What is left is 1. So now it's 14. 2 sevens are 14. Now we can't use 2 anymore. Let's use 7. 7 is also a prime number. 7 twos are 14, 7 ones are 7. So we can continue to use 7. 7 threes are 21. Now we can use 3. 3 ones are 3. So 1176. Now let's see how many twos we are using here. 1, 2 and 3. Then we have a 3 and then we have 2 sevens. Now when we write this in the exponential form, what do we get? 2 raised to the power of 1, 2, 3. So 2 raised to the power of 3 into 3 is raised to the power of 1, which will leave it as it is, into 7, which is raised to the power of 1, 2, raised to the power of 2. So 1176 in the exponential form is 2 to the power of 3 into 7 to the power of 2. Next one, question 7. If A is equal to 2 and B is equal to 3, find the value of, first one is A plus B, the whole square. So we have to substitute here. Okay, so A is 2 and B is 3. So this is 2 plus 3, the whole square. So 2 plus 3 is 5. 5 square is 5 into 5, which is 25. So the answer here is 25. Question 2. B minus A, the whole cubed. And we know that A is equal to 2 and B is equal to 3. So we're going to substitute this. So B minus A means 3 minus 2, the whole cubed. So 3 minus 2 is 1. 1 raised to the power of 3 is 1 into 1 into 1. And how much is that? 1. The answer is 1. Question 3. A into B, the whole raised to the power of A. And we know the values of A and B. A is equal to 2 and B is equal to 3. So now let's substitute. So we're going to have A into B, isn't it? So that is 2 into 3 raised to the power of A. And what is A? 2. So now let's work out what's within brackets here. 2 3s are 6. 6 raised to the power of 2, which is 6 into 6, that is 36. So our answer here is 36. Next one, a into b, the whole raised to the power of b, and the values of a and b are a is 2 and b is 3. So now let's substitute. A is 2 into b, which is 3, raised to the power of b, and b is 3. So here also let's multiply what's within brackets. 2 3s are 6. 6 raised to the power of 3 will be multiplying 6 3 times 6 into 6 into 6. So let's do this multiplication. 6 6s are 36. So let's multiply 36 into 6. Let's do it here. 36 into 6. 6 6 are 36, carry 3. 6 3s are 18, 19, 20, 21. So here we've got 216. 36 into 6 is 216. So our answer to this question is 216. Question 8. Express 1024 as a power of 2. So we're going to do prime factorization of 1024 with 2. Okay, so let's begin that. So 1024 divided by 2. So let's take 10. 2 5s are 10, 2 1s are 2, 2 2s are 4. We've got 512. Now let's divide again. 2 2s are 4, so what's remaining? 1, so this becomes 11. Then 2 5s are 10, but that is 11, isn't it? So we have 1 left which we'll put here, so that's become 12. 2 6s are 12. Now let's continue with 2. 2 1s are 2. Let's take the next number 5. 2 2s are 4. What is left is 1. So that's 16. 2 8s are 16. Now let's continue with 2 again. 2 12. Let's take 12. 2 6s are 12. 2 4s are 8. Continue again with 2. 2 3s are 6. 2 2s are 4. Continue again with 2. 2 1s are 2 and there's 1 left here. So that's 12. 2 6s are 12. So that is 16. Then you continue again with 2. 2 8s are 16. Continue. 2 4s are 8. Again we continue with 2. 2 2s are 4. And once more 2 1s are 2. Okay. So here let's count the number of 2s we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 2s. That means when we express 1024 as a power of 2, we're going to write 2 raised to the power of 10. So 2 raised to the power of 10 will give us 1024. Next one, 343 as a power of 7. So this time we have to divide by 7. So let's try that. 343 divided by 7. So let's take the number 34. So 7, which is the number closest to 34? 28. 7 4s are 28. Now how much is left? After 28, count and reach 34. 28, 29, 30, 31, 32, 33, 34. That is 6, isn't it? So let's put 6 there. Now what is the number? 63. 7 9s are 63. So continue now. We have 49. You can use 7. 7 7s are 49. Again, continue using 7. 7 1s are 7. So 343 will be 7 into 7 into 7. And when you express it as a power of only 7, this will be 7 raised to the power of 3. So 343 as a power of 10 is 7 raised to the power of 3. Question 3, 729 as a power of 3. So that means we have to divide 729 by 3. So this will be 3 2s are 6, but the number is 7, so there's 1 left. So that becomes 12. 3 4s are 12. Next number is 9. 3 3s are 9. So now we have 243. Is this number divisible by 3? How do we know? Let's add it up. 2 plus 4 plus 3. How much is that? 2 plus 4 is 6. 6 plus 3 is 9. That means 243 is divisible by 3 because 9 is in the tables of 3. So let's do that. Let's take 24. 3 8s are 24 and 3 1s are 3. So we have 81. Is 81 divisible by 3? Let's add it up. 8 plus 1 is 9 and 9 is in the tables of 3. So 81 is divisible by 3. 3 2s are 6, but we've got 8. So 3 2s are 6, 7, 8. So that's 2. The number is 21. 3 7s are 21. So now we have 27. Now 3 9s are 27. Then we have 3 3s are 9. Then we have 3 1s are 3. So 729. Now if we count the 3's here, we have 1, 2, 3, 4, 5 and 6. So let's write that. 1, 2, 3, 4, 5 and 6. So if we have to write it as a power of 3, then we write 3 raised to the power of 6. So 729 is equal to 3 raised to the power of 6. Question 9. If 27 into 32 is 3 raised to the power of x into 2 raised to the power of y, find the values of x and y. So here they told us 27 into 32 is equal to 3 raised to the power of x into 2 raised to the power of y. That means 27 is equal to 3 raised to the power of x and 32 is equal to 2 raised to the power of y. Now we need to find the values of x and y. So let's take only 27. It says 27 is 3 raised to the power of x. How many times should we multiply 3 to get 27? That's a question. So now let's divide 27 by 3. Okay, because here 3 is given, let's divide 27 by 3. 3 9s are 27. Continue, we are doing prime factorization. 3 3s are 9. Again, you continue. 3 1s are 3. So we have got 27 is equal to 3 raised to the power of 1, 2, 3. 3 raised to the power of 3. That means 3 to the power of x is equal to 3 to the power of 3. So 3 to the power of x is equal to 3 to the power of 3. That means we have found the value of x to be 3. X is 3. The base is the same, 3 and 3. The powers x is equal to 3. Similarly, let's take 32. 32 is equal to 2 raised to the power of y. So that means we are going to divide 32 by 2 because the base is given as 2. So 2 1s are 2, the number is 3, so there's 1 left. So we put it here, it becomes 12. 2 6s are 12, then you continue. 2 8s are 16, continue. 2 4s are 8, again. 2 2s are 4, continue again. 2 1s are 2. So now 32 is equal to, let's count the 2's. 1, 2, 3, 4, 5. 2 to the power of 5. Now here what does it say? 32 is equal to 2 to the power of y, and we got 32 is equal to 2 to the power of 5. That means 2 to the power of y is equal to 2 to the power of 5. That means y is equal to 5 because the base is the same and the powers y is equal to 5. That's how we got y is equal to 5. So what is our answer? X is equal to 3 and y is equal to 5. Next one, question 10. If 64 into 625 is equal to 2 to the power of a into 5 to the power of b, we have to find the values of a and b. So let's do that. Now 64 into 625 is equal to 2 to the power of a into 5 to the power of b. That means 64 is equal to 2 to the power of a. That means we have to divide 64 by 2. So let's do that. Let's divide 64 by 2. 2 3s are 6, 2 2s are 4. Now we have 32. We know 2 into 16 is 32. Now we know 2 8s are 16. Then 2 4s are 8. Then 2 2s are 4 and 2 1s are 2. So 64 is equal to 2 raised to the power of, how many 2's do we have? 1, 2, 3, 4, 5, 6. So 2 raised to the power of 6. And here we said 64 is equal to 2 raised to the power of a. That means 2 raised to the power of a is equal to 2 raised to the power of 6. Can you see the base is the same? That means a is equal to 6. So we have found the value of a. A is equal to 6. Now we have to find the value of b. So we said 64 is equal to 2 raised to the power of a. So that means 625 will be 5 raised to the power of b. So let's write that. So 625 is equal to 5 raised to the power of b. So let's divide 625 by 5. 5 ones are 5, but the number is 6, so there's one left, it's 12. 5 twos are 10, 11, 12, so there's 2 left, 25. 5 fives are 25. Now we're going to divide this by 5 again. So we have 12, 5 twos are 10, 11, 12, that's 2. So the number is 25, 5 fives are 25. Continue, now it's 25, 5 fives are 25. Again we divide by 5, 5 ones are 5. So here 625 is equal to 5 raised to the power of 1, 2, 3, 4. 5 raised to the power of 4. And here we know that 625 is equal to 5 raised to the power of b. That means 5 to the power of b is equal to 5 to the power of 4. The base is the same. That means b is equal to 4. So we have found the value of b. B is equal to 4. So a is equal to 6. We found the answer, and b is equal to 4. Question 2. 2 to the power of b into 5 to the power of a. Now we know the values of a and b. A is equal to 6 and b is equal to 4. Now we are going to substitute these values here. That means we're going to say 2 to the power of b into 5 to the power of a is actually 2 to the power of b is 4 into 5 to the power of a is 6. So that means we need to multiply 2 4 times. 1, 2, 3 and 4, and multiply 5 6 times. 1, 2, 3, 4, 5 and 6. Now let's multiply the 2's. 2 2's are 4, 4 2's are 8, 8 2's are 16. So here we've got 16. Now to make our multiplication easier, we can break up the 5's into different groups and do. Okay, 5 5's are 25, 25 5's are 125. Into, now take the next set, again 5 5's are 25, 25 5's are 125. Now this is to make our working easier. Now let's multiply 16 into 125. So let's do that. 125 into 16. 6 5's are 30, carry 3. 6 2's are 12, 13, 14, 15, carry 1. 6 1's are 6 plus 1, 7. Second step, 1 5's are 5, 1 2's are 2, 1 1's are 1. Plus, let's add this up, 0, 5 plus 5 is 10, carry 1, 7, 8, 9, 10, carry 1, 2. So this is 2000. So here, 16 into 125, we've got 2000. Now we're going to multiply it by 125. So let's do that. 2000 into 125. Now when numbers end in 0, multiplication is very easy. You can ignore the zeros now and multiply 125 into 2. 125 into 2 is 250. And then how many zeros are there? 1, 2, 3. Add the 3 zeros. So we've got our number here. So once you put your commas, you can read your number. So what does this become? 2,50,000. So that is our answer here, 2,50,000. So this is the answer to the question 2 raised to the power of b into 5 raised to the power of a. With this, children, we come to the end of this exercise. In our next video, we will continue with the remaining exercises. Thank you, children.